हेलो फ्रेंड्स, इंजीनियर प्रणव झा एकेडमी में आपका स्वागत है। आज हम क्लास 9th का फिजिक्स का फर्स्ट चैप्टर देखने जा रहे हैं, मोशन। तो मोशन किसे कहते हैं? सबसे पहले मोशन का डेफिनेशन क्या होगा। तो देखते हैं कि हम कोई भी ऑब्जेक्ट, जैसे ट्री है तो ये स्टेशनरी है, और कोई बस है वो मूव कर रहा है। तो जब कोई ऑब्जेक्ट स्टेशनरी है तो हम उसको कह देते हैं कि ये तो रेस्ट में है, ये मूव नहीं कर रहा है। और कोई मूविंग ऑब्जेक्ट है तो हम कह रहे हैं कि ये गतिमान है, ये मूवमेंट इसका हो रहा है बॉडी का। तो बेसिकली मोशन का डेफिनेशन यहीं से आ गया कि द मूवमेंट ऑफ ए बॉडी इज कॉल्ड मोशन। जैसे द मूवमेंट ऑफ ए बॉडी इज कॉल्ड मोशन। तो कोई भी कॉमन कैरेक्टरिस्टिक्स क्या होता है कोई भी ऑब्जेक्ट का जो मूव कर रहा है, कि वो पोजीशन ऑफ चेंज करता है अपने टाइम, किसी इन सर्टेन इंटरवल ऑफ टाइम में वो अपना पोजीशन कंटिन्यूसली चेंज करता है। कभी यहाँ पे है तो फिर थोड़ी देर के बाद ये मूव करेगा तो फिर किसी दूसरे पॉइंट पे चला जाएगा। तो इस तरह से हम लोग ऑब्जर्व करते हैं। द बॉडी इज सेड टू बी इन मोशन व्हेन इट्स पोजीशन चेंजेस कंटिन्यूसली विथ रिस्पेक्ट टू ए स्टेशनरी ऑब्जेक्ट टेकन एज ए रेफरेंस पॉइंट। हम किसी रेफरेंस पॉइंट जो स्टेशनरी, जिसको हम एग्ज्यूम करेंगे वो स्टेशनरी है, उसके रिस्पेक्ट में हम उसका मूवमेंट चेक करेंगे कि वो कंटिन्यूसली मूव कर रहा है, उसका पोजीशन जो है वो चेंज हो रहा है, तो हम कह देंगे कि वो ऑब्जेक्ट जो है वो मोशन में है। ठीक है, तो इसका डिफिनीशन हो जाएगा, ए बॉडी इज सेड टू बी इन मोशन or moving when its position changes continuously with respect to a stationary point taken as reference. With respect to a stationary point taken as a reference. ठीक है, तो कॉमन कैरेक्टरिस्टिक्स क्या हो गया? ऑल द मूवमेंट ऑफ ए बॉडी दैट दे चेंजेस देयर पोजीशन विथ रिस्पेक्ट टू टाइम। इफ ए बॉडी मूव्स फेयरली फास्ट देन इट्स मूवमेंट कैन बी ऑब्जर्व्ड इजिली। ओके, एंड बट इफ अ बॉडी मूव्स वेरी स्लोली देन इट्स बिकम डिफिकल्ट टू ऑब्जर्व इट्स मूवमेंट इमीडिएटली। तो कोई भी मोशन अगर फास्ट हो रहा है तो उसको ऑब्जर्व करना इजी है, और कोई मोशन अगर एकदम स्लो चल रहा है तो उसका मूवमेंट को ऑब्जर्व करना थोड़ा सा डिफिकल्ट हो जाएगा। इमीडिएटली उसका हम लोग मोशन का मूवमेंट ऑब्जर्व नहीं कर पाएंगे। तो इस तरह से हम लोग चेक करेंगे मोशन मूव हो रहा है कि नहीं। सम इम्पोर्टेंट टर्म्स जैसे डिस्टेंस हो गया, डिस्टेंस, डिस्प्लेसमेंट, स्पीड, वेलोसिटी, एक्सेलरेशन। इन टर्म्स को हमें डेफिनेशन जानना है कि क्या कहते हैं, डिस्टेंस किसको कहते हैं, डिस्प्लेसमेंट किसको कहते हैं, स्पीड, वेलोसिटी, एक्सेलरेशन, ये सब क्या है। तो लाइन बाय लाइन हम आपको बता देते हैं। डिस्टेंस का डिस्टेंस ट्रेवल्ड बाय अ बॉडी इज द एक्चुअल लेंथ of the path covered by a moving body irrespective of the direction in which the body travels. It is a scalar quantity. स्केलर क्वांटिटी किसे कहते हैं? द फिजिकल क्वांटिटी which has magnitude only and no direction is called a scalar quantity. So distance is a scalar quantity because it has no direction and it can be it is only positive. It is always positive. Displacement किसे कहते हैं? तो कोई भी ऑब्जेक्ट ए पॉइंट से बी पॉइंट पे गया और इस तरह से गया और दूसरा रास्ता कि ये डायरेक्ट सीधा चला जाता है स्ट्रेट लाइन से, तो इनिशियल पॉइंट टू फाइनल पॉइंट, तो लाइन ज्वाइनिंग, स्ट्रेट लाइन ज्वाइनिंग initial to final, that will be the shortest distance. So the shortest distance is called displacement. When a body moves from one point to another point, the distance traveled referred to actual length of the indirect path, whereas displacement refers to the straight line path between initial and the final position. So when a body moves from one point to another point, the distance traveled refers to the actual length of the indirect path. ये इनडायरेक्ट पाथ है, उसका एक्चुअल लेंथ क्या होगा, वो डिस्टेंस कहलाएगा. एंड वेयर एज द डिस्प्लेसमेंट रेफर्स टू द स्ट्रेट लाइन पाथ बिटवीन इनिशियल एंड फाइनल पोजीशन. इनिशियल एंड फाइनल, straight line path between initial and final position, that will refers to the displacement. So displacement its definition: when a body moves from one position to another, the shortest, that will be the straight line, basically a straight line, the straight line distance between the initial A point and final B point, the shortest distance between initial position and final position of the body along with direction. Here direction is important, so along with direction is known as displacement. So here direction is very much important. That's why this quantity, that is displacement, this quantity, physical quantity, this physical quantity is a vector quantity. So here displacement is physical quantity, and that physical quantity is vector quantity here because it has direction, magnitude as well as direction. A scalar quantity has no direction, but a physical quantity having magnitude as well as direction is known as vector quantity. Okay, let's take example of distance and displacement. From point A, a body goes to point B and then moves down to point C and then again to point D. So it's a distance. Suppose this position is X and then this is Y, up to this point it's Y, and then M and then N. So what will happen? A straight line joining from initial position A to a final position D. This will be the shortest distance from initial to final. So up to this distance B2, let's suppose this is R point. So a person move from A to B and then B to R, then R to C and then C to D. So in this case distance will be A to B X plus B to R Y plus R to C M plus C to D N. So this will be distance, actual distance with unit. Suppose these all are in meters, then it is in meters, unit is in meters. So this will be the distance, but we observe here that this makes a right angle triangle and this triangle is also a right angle triangle. So we can calculate hypotenuse here AR, that will be what? Under root of x square plus y square, and from this triangle we will get this side under root of m square plus n square. So from A to R the distance is under root x square plus y square, and from R to D the distance is under root of m square plus n square. So displacement become, because since this is a straight line joining from initial position to final position and it is a shortest distance, so displacement here becomes A to D. that will be under root of x square plus y square plus under root of m square plus n square. And this direction is A to D, and the unit is meters. So here we can understand the basic difference between distance and direction, that distance is actual path covered by a body, and the displacement is the shortest distance line in a straight line joining from initial position to a final position. Another example of distance and displacement is here. Suppose a body moves from point A and then comes again to that point. So the here initial and final position is same. Distance become the circumference in this case. So it is 2 pi r. Suppose it has r radius of distance, and the displacement become what? Since the final and initial point is same, so displacement is here 0. Before discussing speed and velocity, let's discuss some important terms, that is uniform motion and non-uniform motion. So what is basically uniform and what is non-uniform? So a body has a motion, suppose uniform, then what will happen? Then it will traverse equal distance and equal interval of time, no matter how small this interval time may be. A body has a uniform motion if it travels equal distance in equal interval of time, no matter how small these time intervals may be. So a body has a uniform motion if it travels equal distance in equal interval of time, no matter how small this time interval may be. What will be the example of this uniform motion? Suppose a car is traveling with a constant speed of 10 meters per second. Then what happened? It's a constant speed. So suppose these are the points. Car starts from here and the speed is 10 meters per second. So after every second the distance will be same, that is 10 meters, 10 meters, 10 meters. In 1 second the car will be from A to B and the distance covered is 10 meters. Again in the next second the car will travel 10 meters. Again after that a car again travels 10 meters in the next seconds. So after every seconds the car travels equal distance, that is 10 meters. And it's a diagram of the distance time graph for a uniform motion is a straight line. So it will be uniform motion. This is a straight line. So the distance time graph of a uniform motion is always a straight line. Non-uniform motion क्या होता है? So what is non-uniform motion? A body has a non-uniform non-uniform motion if it travels unequal distances in a equal interval of time, in a equal intervals of time. So for example, if we drop a ball from a height, then what will happen? The ball will cover unequal distances in equal interval of times. Suppose in first second it covers a distance of 5 meter, then in next second its distance may cover approximately 15 meters, and then in the third second it covers 25 meters in the third second, and so on. So what happens? A freely falling body covers a smaller distance in the initial first second and then larger distance in the latter second. So we conclude here the motion of a freely falling body is an example of non-uniform motion, and the distance time graph of a body having a non-uniform motion is a curved line. When we plot a distance time graph, it's a curved graph. So non-uniform motion has a curved graph when we express it in distance time graph. Non-uniform motion, it is a curved, because a ball dropped from a roof of a tall building travels unequal distance in equal interval of time, so it is non-uniform motion. We can also say the non-uniform motion is accelerated motion. Okay, now we'll discuss what is speed in detail. Speed. So what is speed? Basically these terms indicate what? This term indicate that the speed of a body gives us an idea of how slow or fast a body is moving. Basically it gives the idea of how slow or fast the body is moving. The body is moving, suppose, and it is moving, A is moving and B object is also moving. If it moves faster, it changes its continuous position, it changes its position continuously in a faster manner, and B is changes its motion, its movement, B changes its position in a suppose slow manner. So basically both are traveling, but we can see that A is moving faster and the B is moving slow, so the speed here comes in picture, and we will say that the speed of A is faster than the speed of B. Speed of A is faster than speed of B. So a speed is basically a term which gives us idea that how body moves. Basically it is moving in a faster manner or in a slower, and its definition is that the distance traveled by a body per unit time. A speed of a body is the distance traveled by it per unit time. The formula becomes what? A speed equals to distance traveled by time taken. And don't forget that this is also a scalar quantity, because it has no direction, only magnitude. And that's why it is a scalar quantity. And its unit is, SI unit is meter per second. The device used for measuring the speed is device used to measure the speed is speedometer. The speedometer gives the speed in kilometer per hour, and the device used to measure the distance, for distance the car has a device pre-installed, and that device is odometer. Odometer measure the distance in kilometer. Okay, so another term is average speed. What is average speed? Average speed of a body is the total distance traveled divided by the total time taken to cover this distance. Average speed of a body is the total distance traveled divided by the total time taken to cover this distance. So why basically we need average speed? We might have observed in a city that keeping constant speed is too much difficult. Due to some reason we apply brake and the speed fluctuates. So due to this reason we take the average of this speed. Suppose a car is traveling with a distance travel a distance of 100 kilometers in a 4 hours. So what will be the average speed? Average speed is 100 divided by 4, that is 25 kilometer per hour. 25 kilometer per hour. So we can say that the speed of this car may fall below 25 kilometers, and it may be much more than 25 kilometer per hour. But on the curved road or in the crowded area, this speed may fall below this average value. So it does not mean that average speed of a car is 25 kilometer, that it is always moving with this speed. The speed may fluctuate, but sometimes more than 25 kilometers, sometimes below 25 kilometers. So it's a standard line throughout the whole journey. So average speed distance, what will be the formula of average speed? Average speed formula becomes total distance traveled upon total time taken. Total distance covered upon total time taken. So this will be the formula for the average speed. What is velocity? Previously we have discussed about speed. Basically speed gives just the idea of how fast the car is moving, how fast or slow the body is moving. but we also need to know in which direction that body is moving. So basically for that reason, velocity gives us idea about direction and also the magnitude. So what is velocity? Velocity of a body is distance traveled by it per unit time in a given direction. Velocity of a body is the distance traveled by it per unit time in a given direction. So velocity's formula becomes distance traveled in a given direction upon time taken. Here velocity is denoted by v and the distance traveled in a given direction is denoted by s and the time is t. So we will get a formula of v is equals to s by t or s equals to vt. And unit is same, meter per second. SI unit is meter per second. Here distance traveled in a given direction is nothing but displacement. So formula becomes velocity equals to displacement upon time taken, and the same, that is b equals to s by t because s equals to vt. Here the difference between the speed and velocity is that the speed is a scalar quantity and the velocity is vector quantity, and so speed is always positive, but the velocity may be positive, negative or zero in case of when the displacement becomes zero. So the difference between the speed and velocity is that a speed has only magnitude or size. It has no specific direction, but the velocity has the magnitude as well as directions. Suppose a body is moving with a 25 km per hour, so this will become the speed. But if we say the body is moving with 25 km per hour in the north direction, so this will become the velocity. What is uniform speed? Basically a body has uniform speed if it travels equal distance in equal interval of time, no matter how small this time interval may be. We have stated it earlier. And what is uniform velocity? A body has uniform velocity if it travels in a specified direction in a straight line and moves over equal distance in equal interval of time, no matter how small this time interval may be. So these are the uniform velocity and uniform speed. How can we change the velocity? Velocity can be changed by changing two things. That is, we can change the speed. Either we change the speed or we change the direction. So changing the speed may change the velocity, and changing the direction may also change the velocity. Suppose when an object is moving with 25 km per hour in a north direction, and after some times it changes its direction from 25 km per hour north to east. It takes turns and goes in each direction. So initial velocity is v1, then final velocity becomes v2 in this case. Here speed we can also change. Suppose initially it travels with 25 km per hour, 25 km per hour in the north direction, and then it changes its speed, decreasing its speed and moving with a 20 km per hour in the same direction, that is north. So speed also changes, then velocity changes. Acceleration and remaining topic we will discuss it in next class. Thank you. Have a nice day.